Hello, class. We need to continue where we left off on that final exam review. So we had finished up to question number 15 on this. So let us continue on here. Number 16, I have a pollster who wishes to estimate the true proportion of US voters who oppose capital punishment. How many voters should be surveyed in order to be 95% confident that the true proportion is estimated to be within 2%. This formula is going to take on the form of n is equal to, since we do not have a prior estimate, this would be 0.5 times 0.5 times the z-score. Since we have 95% confidence, our alpha here is 5%. We divide that in half to be 2.5%. So this would be z sub 0.025 divided by 0.02 due to the within 2%. And we're going to square this. The version for Excel to do this would be to take 0.5 times 0.5 times, this would be norm dot s dot inv. This would be based on 1 minus this 0.025, so 0.975 divided by 0.02, and we are going to square this value. So let me open this in Excel so we could see that out as a formula. So 0.5 times 0.5 times, in parentheses, we have that norm, that s, that inv of 0.975 divided by 0.02, and we are going to square this value. And we get this, which we're going to round up to be 2,401. 2,401. For number 17, we have how tall is your average English classmate? To determine this, you measure the height of a random sample of 15 of your 200 fellow students, finding a mean height of 68 inches and a standard deviation of 2.3 inches. We want 90% confidence interval for the mean height of your classmates. So the sample size we are going to use for this is 15, not 200, 15. We're going to use a sample size of 15. X bar here is going to be 68. The sample standard deviation is going to be 2.3. And we have that 90% confidence. So we're going to put that into our one mean t procedure, which will be this Excel document. We're going to use summary statistics for this, so this checkbox will be checked. And we are going to use the sample mean of 68. Sample standard deviation of 2.3. Sample size of 15. And we are going to be using the 90% confidence interval, which gives us a confidence interval in these two green boxes. We have 66.95 and 69.05 as our lower and upper bounds, respectively. So from this, our lower bound is 66.95, and our upper bound is 69.05 in this case. Moving right along, I have question number 18, which I have tests for adverse reactions to a new drug yielded the results given in the table below. At the 5% significance level, we want to state the null hypothesis for testing the claim that the treatment, being drug or placebo, is independent of the reaction, whether or not headaches were experienced. So we just want to state the null hypothesis for a test of independence. So our null hypothesis is going to be that treatment which refers to that drug or placebo, and reaction. The reaction being headache or no headache are independent. That's all that I want for that one, just to state that null hypothesis. Question number 19. I have the data was collected from, we want to, let me backtrack. We want to find the appropriate test statistic, actually specifically for this. And we have data was collected from CEOs of companies within the consumer products industry sector. The following printout compares the mean return to pay ratios between CEOs of the lower tech industry with CEOs in the consumer products industry. The null hypothesis is that the two means are equal. And then we have this big printout involving samples chosen from return. Industry 1 is the low tech, industry 3 is the consumer products. Go through the main standard deviations and whatnot. We actually have our difference in means to be 60.2976. Test statistic T to be negative 4.23 that rounds to. P-value of 0.0003 about, and standard error of 14.239. We want to, based on this printout, find the test statistic necessary for testing whether the mean return to pay ratio of low tech CEOs exceeds the return to pay ratio of consumer products CEOs. So we're given that test statistic. So this would just be T is equal to negative 4.23, based on this line right here in the printout. Question number 20. Based on the sample statistics, we want to find the value of P sub 1 hat minus P sub 2 hat, which is the point estimate of the difference of proportions. And unless otherwise indicated, we are going to round to the nearest thousandth when necessary. But as it actually makes note in the question, we're going to do hundredth. So that's besides the point. In a survey in one city, it was found that the percentage of 12th graders who had used marijuana this year was 46.1% versus 36.7% a decade ago. If 14,600 12th graders were surveyed this year and 15,000 a decade ago, we want to calculate a 99% confidence interval for P sub 1 minus P sub 2. For P sub 1 is the proportion of 12th graders who used marijuana this year, and P sub 2 is the proportion of 12th graders who used marijuana a decade ago, rounded to the nearest hundredth. So from this, we know that N sub 1 is 14,600. And P sub 1 hat is 46.1%, 0.461. So to get the value of X sub 1, we're going to multiply 14,600 by 0.461. And this rounds to be about 6,731, which we need to use for a template. And then the same idea with the other one. N sub 2 is 15,000. P sub 2 hat is 36.7%, so 0.367. And x sub 2 then would be 15,000 times 0.367. This one comes nice, actually. 5,505. So let me open up our two proportion template. That being this one. So sample size for the first sample, as just indicated, that's 14,600. The number of successes, which we calculated, was 6,731. And then we should see that 46.1% on here, which we do. Same thing with the second sample. This one had a sample size of 15,000. Number of successes we calculated to be 5,505. Again, we should see 36.7% here, which we do. And we want to change our confidence level to be 99%. And we get these as answers. So to round this to be about, we have about a lower bound of 0.08 based on this lovely percentage. And from this one, we have about 0.11 based on this percentage, since this one wants to be about 8% and this one to be about 11%. Let me write down those bounds. So our lower bound, 0.08, and our upper bound, 0.01. And then for number 21, which is the last portion of our first part here, I have assume the proportion of students retained at a student university in the spring semester is P sub 0.3, and the proportion of students retained in the fall semester is P sub 0.4. Based on a recent study, a 90% confidence interval for P sub 0.3 minus P sub 0.4 is negative 0.0398 to 0.0262. We want to give an interpretation of this confidence interval. Do note that this is this difference in proportions. And we have a negative value and a positive value. Negative indicating that the second proportion is bigger, and the positive indicating that the first proportion is bigger. So we got a little bit of an interpretation there. We have that we are 90% confident. 90% confident that the proportion of students retained in the spring semester this one being that P sub 0.3 in this case is between 3.98% less, that one's less because it's negative, and 2.62%. Let me write my decimal to be more legible. 2.62% more, which is based on that positive value that we have, then the proportion of students retained in the fall semester. Which is that P sub 0.04 in our confidence interval. So this is that first part of this final exam review, and I will see you for that second part of this. Let me know if you have any questions or concerns. Thank you.